Recall that we just defined a system as being linear if it is both additive and homogeneous. Okay. Now, what this means is that if I have a linear system which, let's say, produces the output, let's say x1 of t produces the output y1 of t, x2 of t produces the output y2 of t, so on and so forth, and I have, let us say, a total of n signals, xn of t, each producing outputs y1 through yn. Okay. Now, because the system is homogeneous, if I multiply these inputs by constants, say a1, a2, so on until an, the outputs also get scaled by the same constants. Right? That's just a property of the system being, or that's just a consequence of the system being homogeneous. Now, a consequence of the system being additive is the fact that if I added all these input signals, then the corresponding output for that signal will be the outputs added up together. So what I mean by that is, if I considered a signal called x of t, which is summation ai xi of t. If I wanted to find the output for this input, linearity tells me that all you have to do is to know the outputs corresponding to the x1, x2, so on until xn. So linearity tells me now that the output corresponding to x of t is going to be y of t, which is given by summation ai yi of t. Okay. So this is a very important property of linear systems. In fact, this is our definition of linearity, is that if x1 produces y1, x2 produces y2, then any linear combination of x1 and x2, or a weighted linear combination, meaning a1 times x1 plus a2 times x2, produces a1 times y1 plus a2 times y2. Okay. So another way to write this, if we were to write this in terms of operators, is to say that if x of t is equal to summation ai xi of t, then y of t, which is h applied to x of t, which is h applied to summation ai xi, is the same as summation ai times h applied to xi. So notice that I can move the h inside the summation. So this is essentially what linearity means mathematically. But intuitively what it means is, as if a signal can be thought of as the sum of two input signals, the output corresponding to this signal can be derived by looking at the outputs corresponding to x1 and x2 and then just adding. The linearity property can be shown pictorially using this following picture here. So what the picture shows here, let's look at the first picture here. So the first picture here shows that if the signal x of t is the weighted sum of x1, x2, so on until xn. Now then let's say the result of passing this signal through the system is the signal y of t. Okay. Now what linearity means is this. It means we can switch the role of these scaling functions and this system. In other words, we can take the result of passing x1 through the system first. Let's call it y1. We can scale y1. Take x2, pass it through the system. We get y2. We can scale y2 by a2, so on and so forth. And then we can add all of them up together. And if a system is linear, these two have to be the same. Okay. Now let's work out an example. Yeah. So here's a nice example. Suppose I have a system H. And I know the following things about this system. I know that when the input is, say, e to the j 2 pi t, the corresponding output is e to the j 3 pi t. And suppose I also know that when the input is e to the negative j 2 pi t, the output is e to the negative j 3 pi t. So we are given this information. We are also given that this is a linear system. Okay? So we say consider a linear system H. And suppose I asked you, what will be the output from the system if the input were sine 2 pi t? So I would suggest that you pause the video here and think about this yourself. Okay. Now, how can we solve this problem? Well, if I use the linearity, what I can do is this. I can write sine 2 pi t using Euler's formula as 1 over 2j times e to the j 2 pi t minus 1 over 2j times e to the negative j 2 pi t. Okay. To put this in the same framework as this, you can see that I'm thinking of this signal as x1 of t. I'm thinking of this as x2. I'm thinking of this as a2. And I'm thinking of this as a1. Actually, I'm thinking of a2 as negative 1 over 2j. So for example, I could think of this as plus negative 1 over 2j times e to the negative j 2 pi t. Now linearity tells me that the outputs should also be weighted by the same amount and added up, which means my output should be 1 over 2j e to the j 3 pi t minus 1 over 2j e to the negative j 3 pi t, which again using Euler's formula is nothing but sine 3 pi t. Okay, so here is an interesting question for you to think about. What is the output corresponding to an input which is sine of 2 pi times t minus, say, 1 over pi? I will leave you to think about this.